What's up, everybody? Welcome to Coding with Chaim. In this week's video, we're going to be covering 5 of the most important JavaScript interview questions. In fact, I would go so far as to say is if you can answer these 5 questions correctly, it'll go a very long way in helping you land your next JavaScript role. So let's make sure that that happens and start covering these questions. So the first question that we're going to be taking a look at is, what is a closure in JavaScript? So let's take a look at an example right here. As you'll notice here on screen, I have a variable called x, and the value of this variable is going to be 100. I then also have a function called log x, and what this function is simply trying to do is it's going to do a simple console.log x. Finally, over here on line 5, I'm going to go ahead and say log x. So now, here's the interesting bit that I want you to sort of notice, and I want to draw your attention to. You'll notice that the function log x is not actually receiving any arguments. When we specify the function, we're not saying that we're expecting it to kind of get any arguments. And then, of course, because of that, when we actually call the function, we're not going to be passing anything in. Which means this variable x that we're trying to reference inside of the log x function hasn't been passed in. Despite this, when we run this, we still get the value of 100 correctly getting printed. That's a closure. So to kind of help you understand this, I actually drew a very tiny illustration. So let me show you what I mean. So here you notice we have a big circle, which encompasses 2 smaller circles. The smaller circle, or the middle one, is then encompassing a smaller circle. So we can think of each one of these circles as functions. And the reason why I want to think of each one of these circles as functions is because essentially what a function does is it creates its own scope. In JavaScript, every new function creates its own scope. Scope basically meaning that that's where you kind of have the access to any individual variables that have been defined within that particular scope. So the way that JavaScript scope kind of works, and typically the way that lexical scope works, and that's the kind of scope that JavaScript actually uses, is that scope works its way from inwards onward, inwards to outwards. And so what that means is if I have anything specified here in this smaller circle, I actually can't reference it out here in the bigger circle, and of course not out here in the big circle. But the opposite of that is true. In other words, if let's say I have something that's specified here out in the big circle, I can use it in the middle circle, and I can use it, of course, in this circle. So now let's say if I have something that's specified in the medium-sized circle, I can use that in the smaller circle, but I can't use it in the bigger circle because scope travels from the top down, which means that things that are over in the smaller circle can reference things that live above it or outside of it, but the opposite is not true. If I have something that's specified only in the inside circle, those guys outside of it, the bigger circles, can't reference it. And so that's exactly what's happening right over here. Essentially, we have this function called log x, right? So that's basically, we have the file that is kind of our big circle. We then have another function called log x, which is our smaller circle. So as I've said, scope basically travels downwards. So essentially the variable here has basically been specified in the big circle in our file. So the smaller circle, our function log x, has the ability to kind of access those variables because it has access to that scope. Again, the smaller circle can always access the bigger circle. Therefore, the variable of x is technically considered in scope for the log x function. And so the whole point here is that a function in JavaScript that can access a variable through scope can use that variable despite the fact that it hasn't been passed into it as an argument. And that's exactly what a closure is in JavaScript. So to now take this a step further, let's actually see an example of how we can actually take this concept of closures that is offered to us in JavaScript and do something rather cool with it. So we have a function over here called makeAdder. MakeAdder is a function that will first receive x as a variable or as an argument. And then when you call makeAdder, what you're going to get is you're in return going to be getting a new function. This new function that's going to be getting returned to you will be receiving a y as an argument. And then finally, when you call that inner function, you're going to get the result of x plus y. So essentially, the thing here that's important to note is our inner function is going to be able to reference the x variable despite the fact that x was not getting passed into it. Only y is actually getting passed into our inner function. But despite this, like we just mentioned, because the inner function lives inside of the makeAdder, which is the outer function, inner functions can reference variables and values that live in the outer function. That's why our inner function can actually go ahead and reference the x variable. And so now here's what we're doing. We're going to go ahead and call makeAdder passing in 5. So our x is going to be 5. At that point, we're going to be receiving a new function called add5. Now at this point, add5 is just a function. It hasn't done any addition yet. But at this point, what I already know is whatever number I pass into add5, is going to take the number that we passed in and then add 5 to it. So for example, in our case here, we're taking add 5 and we're passing in 10. So now if I go ahead and run this code, we're going to get 15. The reason for that is because when we called makeAdder, we passed in 5. So at this point, the x already has the value of 5. And then in return, we now get this function over here. And instead of reading this as x plus y, we can read this as 5 plus whatever y is going to be. Because at this point, by the time you have gotten access to that inner function, that means you've already called the outer function. You've already called makeAdder. And in order to call makeAdder, you passed in something for x. So in our example, what we passed in for x was 5. Therefore here, instead of reading this as x plus y, we can actually read this as 5 plus y. So now finally, we actually go ahead and call call this add5 function, which again, this add5 function is nothing more than this inner function here. At this point now we're going to go ahead and pass in 10. 5 plus 10 is of course 15, and that's how I actually get the number 15. And all this is due to the power that closures afford us within JavaScript. The next question that we're going to be covering is, what is hoisting in JavaScript? So let's take a look at this example. In this example, you'll notice that on line 1, we're going to go ahead and invoke a function called foo. And then on line 2, we're going to go ahead and define that very same function called foo. And then on line 3, we're going to go ahead and say hi there. That's going to be happening inside of the function. So now if we actually go ahead and run this code, you'll see that it all works exactly as expected, despite the fact that we've actually gone ahead and invoked the function before the function has been defined. Because again, of course, we're invoking the function on line 1, and only later in a line further down on line 2 do we actually go ahead and define the function foo. So despite that, it actually still works, and that's exactly what hoisting is. So essentially what JavaScript will do for us is going to take our function and then essentially hoist it to the top of the scope. In this case, it'll just be the top of the file. And so essentially JavaScript has made it so that our function foo is actually correctly defined before we're actually going to go ahead and invoke it. There is a catch, there's a caveat, and there's a certain scenario where this is actually not going to work. So let's take a look at that example. So the syntax highlighting is a little bit messed up, but we could ignore that. So we have the first example commented out, and here what we're saying is we're once again going to go ahead and try to call foo. But here now we're saying on line 7, we're going to say const foo is equal to a function. So it looks very much the same as what we did here. The only difference is now we're actually going to go ahead and say that we are going to be creating a variable, and then to that variable we're going to go ahead and assign a value, and that value is going to be a function. So now if we actually go ahead and run this code, well, now we're going to get an error saying cannot access foo before initialization. So now you might be thinking, well, of course that doesn't work because you use const, and const never hoists. And to that I might say, you might be right. It's true. Const doesn't hoist. And that's another thing that's important to kind of know about hoisting in JavaScript, and that is let and consts never get hoisted. Only vars get hoisted, or function declarations get hoisted. In this case, you're right. It's not getting hoisted because of const. But you know what I'll say? You're right. Let's try to see what happens if we use var. Now I have it as var foo instead of const foo. I'm going to go ahead and run this, and once again we're going to get an error, only it's true. This time we're getting a different error, and that error is going to be saying foo is not a function. So if we actually understand, if we read this error very clearly, what JavaScript is basically telling us, it's saying, okay, I understand that you have a variable foo. I'm aware that that variable exists within your application. I'm not complaining to you reference error foo is undefined. I get it. I know foo exists. However, I'm not aware of it being a function. I just know it as being an undefined variable. It's just undefined. You've declared the variable. You haven't given it any value. And you might be thinking, well, wait a second. I totally did. I said var foo is equal to a function. And that's the catch. That is one of the important caveats that you need to be aware of when it comes to hoisting in JavaScript. When we say that something is getting hoisted in JavaScript, only declarations get hoisted in JavaScript. Assignments don't get hoisted. So essentially, in very simple terms, what that means is anything that's on the left-hand side of the equal sign does get hoisted. Anything that's on the right-hand side of the equal sign does not get hoisted. So in this case, because we have a var foo, so the var foo lives on the left-hand side of the equal sign. So that does in fact get hoisted, which is why JavaScript is not giving us a reference error. It's not complaining that it doesn't know what foo is. It knows full well that foo exists. It just doesn't know that it's a function because the right-hand side of the equal sign doesn't get hoisted. However, in contrast, in our first example, because there is no right-hand side or left-hand side, we just have function foo, there is no concept of a left or right-hand side, therefore we consider the entire statement one declaration, or essentially one left-hand side, right? The left-hand side being the declaration, we're considering that one declaration. And of course, the rule is declarations do get hoisted in JavaScript, assignments don't get hoisted in JavaScript, which is why when we have a function declaration, hoisting will work, but down here when we have a function expression meaning that we are defining a variable, and then to that variable we are assigning a value that's going to be a function, in that case hoisting is not going to work because only left-hand sides, only declarations get hoisted, assignments don't get hoisted. So the next question is, what's the difference between a promise and a callback in JavaScript? So before we actually go ahead and take a look at an example to kind of see this in action, see this in code, let's talk about this in a sort of more auditory way, in a sort of more verbal way for just a second, because I think that that'll actually help us understand this example a little bit better. So when it comes to dealing with asynchronous code in JavaScript, we of course have two ways of dealing with it. We can of course use a promise, or we can use a callback. So the callback is kind of akin to basically saying, you go ahead and do the work, call me when it's done. So that means that so long as you're doing the work, I have nothing to show for it. And I might actually borrow Kyle Simpson, the author of You Don't Know JavaScript. I'm going to borrow his example. His example goes a little something like this. Imagine you kind of go to a fast food restaurant, and then you stand up by the counter, and you make your order. Say you order a burger, right? So now, a callback basically says that they're not going to give you anything in return to kind of represent the fact that you have a burger coming your way. What they're going to do is once the burger is done, they're just going to go ahead and call you and say, hey, your burger's done. So long as the work is happening, you have nothing to show for it. You're just waiting for them to give you a callback to say, hey, your food's done. On the flip side of that, a promise would basically be the equivalent of you kind of going up to that counter saying, hey, can I please order a burger? As soon as you make that order, in return, you're going to be getting some kind of ticket or some kind of receipt. That ticket or receipt represents your future burger. But at this point, you already have some value in hand. Sure, it's a future value. It's a value that's going to be representing a value that you're going to be getting at some point in the future. But at this point, right now, you already have that promise that represents the fact that you're going to be getting that burger at some point in a later time. That's exactly the difference between a callback and a promise. So let's actually go ahead and take a look at a code example to kind of see this more in action. So as you can see here, we have a function called getNumber. Now, the first example that we're going to be doing is we're going to be actually using this getNumber with the callback style. So essentially what getNumber is going to do is it's going to give us the number 10, but on a delay after 100 milliseconds. Essentially, that's the sort of amount of time that it takes to kind of cook our burger from our previous example. So here what we're doing is we're basically saying, go ahead, cook the burger for me, call me when it's done. I'm going to go ahead and pass you this callback. Call me when it's done. So when the 100 milliseconds are up, it's actually going to go ahead and invoke whatever callback it is. It's going to do the process of actually calling us and then giving us our burger, giving us the number 10. So here we're actually going to go ahead and use the getNumber function. This is where we're actually going to go ahead and place the order. We're going to say, go ahead and give me the number. And here's the function. This is what I want you to do when the work is done. I want you to basically go ahead and call the function. When you call my function, give me the number n, and then also go ahead and log the value of n. That's what I want you to do. So essentially, we're basically saying, you do the work, call me when it's done. That's a callback. On the other hand, here we now have a function called getNumberPromise, and then what this function is basically doing is it's going to go ahead and return a promise that's going to resolve to the value of whatever getNumber returns. But you can already see immediately the first thing that this function is doing very differently than what this function is doing is the sort of callback version of the function had no return. It wasn't returning anything. Whereas if you look at the getNumberPromise version, immediately we're already going to be getting back a promise. The first thing it does is return new promise, and then it does some resolve reject, and then it's going to basically take the resolve, pass it to the getNumber. There's some more magic that's happening, but the most important takeaway for us right now is as soon as you call getNumberPromise, you're already going to have something to show for it, which basically means down here we can very simply say const promise is equal to getNumberPromise, because as soon as you invoke this function, you immediately get back a response. Of course, that response will of course later represent the real value. At this point, it's only a future value. But the key difference here is, unlike the callback version, as soon as you actually go ahead and call the function, you already get something in return. It's like you're getting the receipt at the fast food counter. So now if we actually go ahead and run, you can actually see that we do in fact have the value of 10 when we say promise.then n console.log n, because now we're basically going to go ahead and unpack that promise, unpack that sort of future, and actually get the underlying value when it's available. But the first thing right away is we already have some kind of value to show for the fact that we requested this asynchronous work. The next question is, how does the this keyword work in JavaScript? So let's take a look at this code example right here. So here's what we have. We have a person object, and this person object will have two keys on it. First of all, it'll have the name prop, which is going to be Chaim, and that's going to have a function called sayName, and inside of the sayName, we're going to go ahead and say console.log this.name. So of course, the question being now, what is this? And as a result of that, what is name going to be evaluated to? So let's see what happens. Down here, we're going to go ahead and say on line 8, person.sayName. We're going to go ahead and run this, and as you can see, it does in fact work. It's saying that this.name is going to be equal to Chaim. So now let's make one seemingly simple change or one seemingly innocuous change and see what actually happens. What I've done now is I've gone ahead on line 9 and I've declared a variable called local sayName, and all I'm saying is I'm going to go ahead and say person.sayName. Basically assign the function person.sayName, don't call it, but assign the function of person.sayName to a local variable called local sayName. Then finally on line 10, go ahead and call the local version of that function. The function is the same. The definition of the function is exactly the same. Nothing's changed. All I did was I basically said, instead of me having to go ahead and call person.sayName, give me a local variable that's going to point to that same function, and then I can invoke that local variable. Seems like a small change, but if we run this, we're now going to actually get undefined. So why is that? Well, that's exactly how this works. That's the whole point of this question. It turns out that this keyword will basically take on the meaning of whoever's calling your function. So in our first example here on line 8, when we said person.sayName, because person is the one actually calling our sayName function, that this keyword inside of the sayName function becomes person. It's the equivalent of this suddenly magically not saying person or not saying this. It's as if it now magically says person.name. And so of course you understand that person.name will always evaluate the Chaim. So since we're saying person.sayName, now that this keyword becomes person, because the this will always look at who is the one calling the function. That is the sort of basic standard way of how the this keyword works. So therefore, what ends up happening now is when we actually comment out person.sayName, but we actually take the person.sayName and we put it to a local variable called local name. So let's turn this back into a this and not say person. So now we're saying person.sayName is going to be equal to local sayName. Well, now when I actually go ahead and call local sayName, it's no longer going to be person.sayName, which means that when we call this function, this is not going to be turning into person. This is going to be turning into the global context, because we are basically calling it out in the file, which means this would be the equivalent of me saying global.name. And of course, we understand that there's no variable name that's now been specified on global. Therefore, if we run this, we just get undefined. So again, by default, what this keyword does in order to kind of take on meaning is it looks at the call site as a function, trying to understand who's the one calling the function, and then based on that, I'm going to take on that meaning, and then based on that, certain variables may or may not have their value. So in the case where we're saying person.sayName, that this keyword becomes the person, therefore the name variable exists, and it just gives us the value of Chaim. But if we just call it out in the file with our local variable, then it's basically as if the global context is the one calling the function, in which case the name variable doesn't exist, and all we get is undefined. But there's actually a way around this. Okay, so here you can see we're basically saying that we're going to be creating a local variable called bound sayName. So far it's going to be very similar to what we just did up here on line 9. And now we're going to say person.sayName.bind person. So essentially we're going to be creating a new function that's going to be called bound sayName, which is going to be referencing the sayName function. But the difference is now we explicitly told JavaScript, I want you to bind to the person object. Now we actually go ahead and call bound sayName, despite the fact that we're not saying person.sayName, we're just calling bound sayName out locally or globally in our global context. When we actually run this, what we're actually going to get is going to be Chaim. Now the reason for that is because we're using the bind method. Essentially, all of this sort of talk about what this becomes is in an instance when JavaScript has to itself infer what this is, because it wasn't explicitly told. Here, when we're actually going to use the bind method, what we're basically telling JavaScript, don't worry about inferring this on your own. I, as a developer, will tell you what this is going to be referring to. I'm telling you in this case, no matter who's calling your function, just know this will always be referring to the person object. Therefore now, despite the fact that here this didn't work earlier, now we actually have this local variable that's living out in the global context, because we explicitly told JavaScript by using the bind method that this will always be referring to person. It'll still going to work because this is still going to be as though it says person.name and not this.name, because we explicitly told JavaScript. Finally, the last thing to kind of that's important to mention when talking about the this keyword is how arrow functions might change the sort of behavior of the this keyword. So if you remember earlier, when we had the sort of first example, we had this person object, and then we basically had sayName, which was equal to a function, and then we just did this.name, and then when we simply said person.sayName, just like that, literally calling it right off of the person object, if we actually ran that, it of course did work, and I will just demonstrate this really quickly once again by commenting that out. We're just going to run this, and it of course says Chaim, just the same. But if we make this change, let's go ahead and bring this guy back in, and then we're going to comment this guy out. So here we basically have something that looks very similar to what we had up over here. The only difference is now sayName is no longer using the function keyword, except now it's using the arrow function. But otherwise everything is the same. We're still saying person.sayName, we're calling it off of the person object. But if we go in and we run this, well, now we get undefined. So it turns out that basically, whenever we say that the this keyword will go ahead and take on the meaning of whoever is the one calling the function, that's only true if you're using the function keyword. However, when using the arrow function, the meaning of this will not change no matter who calls the function. Which basically means that here, even though person is the one calling the function, and previously it basically, what ended up happening was that this kind of took on the meaning of person, here the arrow function basically dictates that the this keyword will basically remain the same as it was at the time of definition. So since at the time of the definition, this is pretty much referring to the global context, now even though we're basically saying person.sayName, but since we use an arrow function, it doesn't take on the meaning of person, it stays the global context, and therefore we get undefined, because of course global.name doesn't exist, and that's how we get undefined. Finally, the last question that we're going to be covering in this video is, what is the prototype in JavaScript? So the answer simply is, the prototype allows JavaScript objects to inherit from one another. So let's take a look at an example of this. So as you can see here, we have an object called vehicle that has a method on it called drive, and all it is going to be a function that's going to log the car is driving. We then finally have another object called car, and all that this object has is going to be a key called make, and its value is going to be Honda. The most important thing to notice is the car itself does not actually have the method drive on it whatsoever. It is not specified. Finally, on line 11, we're basically saying object that set prototype, but we're kind of referencing after the sort of global object, the sort of all objects basically end up pointing back to the sort of global object that exists within JavaScript. And we're using its set prototype of method. And then what we're basically doing is we're saying, let the car be a prototype of type vehicle. Now, because we did that, we actually come on to line 12, we can actually go and say car.drive. So again, remember, on the car object itself, we never actually did specify that's going to have a method of drive. The drive method only exists on the vehicle. But since on line 11, we basically told JavaScript that the car is going to be a prototype of type vehicle. In other words, it's essentially going to be sort of like an instance or inheriting from vehicle. Now we come on to line 12, we can actually go and say car.drive. And as we do that, we are in fact going to get the output of that the car is driving, which basically means that the drive method now safely exists on the car object. And the way that that works is because we told JavaScript that the car is going to be of the vehicle prototype, which means that since now they're linked together via the prototype chain, so what's going to end up happening is when we try to go ahead and reference this drive method on the car, JavaScript is going to say, okay, car itself doesn't have this drive method. Well, oh, it's okay, because I can now see through the prototype chain that car is linked to vehicle. I'll travel up to vehicle and say, oh, vehicle does have the drive method. Great, I'll just use vehicle's drive method on the car and everything will just work fine and dandy. Well, that does it for this video. Hope you enjoyed it. I hope you found it useful. If you did, please drop a like, subscribe, and I'll see you next week in another video.
Perfect.